This is your module number 2. Okay, module 2, topic naming strain energy. Now, chali, first of all, let me understand concept of the strain energy. So now, first few things are theoretical. Okay, so now what is a strain energy? So just read the definition here. Already I have right here. For elastic body, when load is loaded with gradual, sudden, or impact. Now, can anyone tell me in chat box what is the meaning of gradual, sudden, or impact? Can anyone tell me what is the meaning of gradual loading, sudden loading, or impact loading? Yes, right, yes. Can anyone tell me meaning of the gradual, sudden, or impact loading? What is the meaning of gradual loading? Sudden, that means instant, yes. Impact, that means, tell me. चलिए बताइए मेरे को, ग्रेजुअल, सडन और इम्पैक्ट का मीनिंग क्या होता है? फाइन, चलिए. For an elastic body, when loaded with a gradual, sudden, or impact type loading, it deforms. Now, just simple thing. Whenever load is applied on body, due to application of load, but obvious it will be a deform. Yes or no? And due to that deformation, there should be a work done on it. And upper work done, take work thase. Due to this, elastic body behaves like a spring and oscillator. Okay, this is just kind of the assumption. Work done due to external load or effect is stored in a body in term of the strain energy. Okay, જે પણ વર્ક થશે એ બોડીમાં strain energy ના ફોર્મમાં સ્ટોર થશે. If stress produced are within elastic limit, keep in mind we are dealing up to elastic limit. Okay, જે પણ assumptions છે એ within elastic limit છે. Hooke's law obey કરવો પડશે તમારે. Now, if elastic limit is not exceed, the work done by a load is stored in a body that is known as a strain energy. Okay, if elastic limit is not exceed, that means within an elastic limit, work done by loads and which is stored in a body which is as a strain energy. As the elastic limit is not exceed, that means stress produced within an elastic limit, the body will regain its original position just like an elastic spring on a removal of loads or effects. So amount of internal energy stored, that is a depends on amount of internal energy stored, that is a depends on type of loading, which kind of load you are applied. उसके ऊपर depend रहेगा which how much amount of the internal energy will be stored. So in short, what is the definition of strain energy? Internal energy which is stored in any material is loaded within the elastic limit, that is called strain energy. So lots many time definition of strain energy is asked, so you have to remember definition of strain energy. Okay, ये सब कुछ थोड़ा घना explanation था. Okay, so now again you can also say that when body is subjected to gradual, sudden, or impact load, it deforms and work done upon it. So if elastic limit not exceed, this work is stored in a body. This work done or stored in a body, that is called elastic. That is called strain energy. Is it clear? Please confirm me. Definitions clear છે strain energy ને કોને કહેવાય? Whatever work done on a body, that is known as a elastic. That is known as a strain energy, but within a elastic limit. Fine. Is it clear or not? Please confirm. આપણે એક સિમ્પલ એક્ઝામ્પલ થી પણ સમજીએ છીએ. એક બાર પર લોડ એપ્લાય કરીશું અને એનું ડેરિવેશન કરીશું. ઓકે, is it clear or not? Please confirm me. कितना क्लियर है? Okay, I hope it is clear to all of you. चलिए next. Now there are a few important terminologies which is always asked in exams. Okay, पूछा है. First is the resilience. So what is resilience? Total strain energy stored in a body, that is called resilience. Okay, whatever work done on a body as a part of work done, as a part of work done, energy stored, that is known as a strain energy. So total strain energy stored થશે એના કેસ આપણે resilience, અને એનો ઇક્વેશન છે mu equals to sigma square by 2e into v, where v equal to volume, e equals to modulus of elasticity, and sigma is equal to stress. Okay, now we will derive the same equation also, don't worry. Okay, now derivation wala part nahi puchta hai, lekin we will derive how this equation actually comes. Fine. Next, what is the unit of the resilience? Unit of resilience is a Newton mm or Newton meter, or it is also known as a joule. Okay, તમારા unit યાદ રાખો પડશે. ઘણી બધી વાર definition પૂછાય છે. Explain resilience, give its unit. So total strain energy stored in a body, that is called resilience, and equation of resilience is sigma square by 2e into volume, and unit is Newton mm. ચલો આપણે આ unit ને derive કરીએ. What is the unit of stress? Stress equals to force by area, yes or no? So can I say that Newton per mm square? Everybody with me? Stress is proportional to strain, yes or no? Stress is proportional to strain. So can I say that stress equals to E into strain? So can I say that whatever unit of the strain, that same unit goes for modulus of elasticity? But keep in mind, here stress square, so we need to keep as a square, divided by Newton per mm square. Everybody with me? मैं sigma square ની value પર મૂકી છે, this value for sigma square, this value for E, into volume, that is mm cube. Yes or no? Please confirm me. ये below वाला term cancel हो जाएगा, तो we can say that Newton per mm square multiply by mm cube, so we will get Newton into mm. Is it clear or not? Please confirm me. And all of you are already learned Newton mm or Newton meter is nothing but joule at your physics level. Right now, so it is not need to remember the unit. You can derive from this equation, from fundamental concept. Right? चलिए next, proof resilience. First term था resilience, next term है proof resilience. So maximum, now just see highlighted word. In resilience, total strain energy stored in body. In a proof resilience, maximum strain energy stored in the body. That is called a proof resilience. Is it okay? I hope this definition is also clear. Fine na? Maximum, that means જેમ તમે લોડ આપશો એમ તમારા બોડીમાં ડિફોર્મેશન થશે, જેમ લોડ આવશે એમ તમારા બોડીમાં વર્ક થશે. ઓકે, એક એવી સિચ્યુએશન હશે કે જ્યાં તમારો લોડ મેક્સિમમ થઈ ગયો હશે, તો એ જગ્યાનું તમારું જે પણ ડિફોર્મેશન હશે, ઇટ મે બી, ઓકે, આઈ નોટ ટેલ યુ it must be, it may be a maximum, but at that condition we can say maximum strain energy attained. Okay, so proof resilience is nothing but maximum strain energy stored in a body, that is called proof resilience. Equation will remain same, but we are considering the maximum strain energy, so in that case we will consider maximum stress. Is it okay? Itna hi difference. I hope it is clear to all. Clear che? Please confirm me. Clear ne? Can we move ahead? Okay, chalo. Unit will remain same. Now next term is modulus of resilience. ત્રણ term આયો. First resilience, second proof resilience, and third modulus of resilience. Now what is modulus of resilience? Same, maximum strain energy stored in a body per unit volume. Keep in mind, maximum strain energy per unit volume. That means what we can say, maximum strain energy per unit volume. What is your equation of strain energy? Now actually these all are the equations for strain energy. ये equation strain energy का ही है. This equation actually for strain energy. Okay, but we have write this equation in term of the different terminology. Like in a case of resilience, what we will require total strain energy. That means total stress we will consider. So actually this equation actually for strain energy, sigma square by 2 into v is the equation of the strain energy by default. So maximum strain energy per unit volume. So can I say that strain energy by volume? Yes or no? Maximum strain energy by volume, that is nothing but modulus of resilience. Proof. Now, what is the maximum strain energy? That is nothing but proof resilience. Yes or no? What is your maximum strain energy? What is your maximum strain energy? That is your proof resilience. Yes or no? Everybody with me? Maximum strain energy, that is nothing but your proof resilience. And that is nothing but sigma square E, sigma E square by 2E into V. So just put all the value here. Sigma E square by 2E into V, that is the term of the maximum strain energy, divided by volume. So volume wala part nikal jayega. So sigma square by 2E is the modulus of resilience. I hope it is clear to all of you. Clear? I think ગોખવી નહીં પડે definition. One by one તમને યાદ રહી જશે. આનો યુનિટ કંઈક અલગ રહેશે. ગોખી ના મારતા, એટલે મિસ્ટેક ના કરતા એક્ઝામ. બરાબર? What is unit? ચલો આપણે એનો યુનિટ બનાવીએ. સિગ્મા E square by 2E. ટૂટો કોન્સ્ટન્ટ છે, એની કોઈ જરૂર નથી. સિગ્માનો આપણે કીધું એ પ્રમાણે ન્યૂટન પર mm સ્ક્વેર. E no Newton per mm. So this one is cancelled out. Actually, this is the sorry, my mistake. Sigma square, that is Newton per mm square whole square, because of sigma square, divided by Newton per mm square. So your unit of the proof modulus of resilience is Newton per mm square. That is nothing but you can say like a unit of the stress. Okay, I hope it is clear. क्लियर है? यहां तक कोई डाउट? I hope it is clear to all of you. चलो, now we will derive general derivation of the strain energy. Okay. Now again, this theory not asked in exam, but let me try to elaborate some concept of the strain energy by some example. For that, let me consider circular bar. Okay, let me consider circular bar. Which is fixed at below. This is case number 1. Okay, this is your case number 1. Let we share a whiteboard. Fine. Is whiteboard is visible? Please confirm me. Is whiteboard is visible?
Yes, sir.
Okay, fine. चलो. Now, actually, આપણે અહીંયા શું કરી રહ્યા છીએ સમજી લો. We are trying to derive equation sigma square by 2e into v. Okay, આપણે આ equation derive કરવાનો try કરી રહ્યા. Right? So, you people are able to know what we are actually doing here. ચલો. થોડોક બોરિંગ ટોપિક હશે, પણ ફંડામેન્ટલ કન્સેપ્ટ સમજવા માટે જરૂરી છે. બરાબર? So let me consider a circular bar. Let me consider a circular bar. This is your circle. Okay. This is fixed at below. We are going to consider 4 different conditions. This is your first condition. Shapes are same. Okay, it may be possible I am not able to draw same shape. Dimensions are also same. પહેલા હું સ્કેચ ડ્રો કરી દઉં છું બધા, પછી ડેરિવેશન પર કોન્સન્ટ્રેશન કરીએ. And this is your fourth condition. Sure. Now, this is the case number A, where say P equal to external load. Okay, and this is a cross sectional area A. દરેક કેસ માટે cross sectional area A જ રહેશે. Now, just tell me, if I am applying the load on your body, okay, if I am applying the load on your body, there will be some internal resistance obeyed by material property, yes or no? Everybody with me? Yes or no? If there is a external force applied on body, there must be an internal resistance obeyed by material, yes or no? That resistance is R. So this is your internal resistance of material. And that is R. Now, this is your resistance. Now, resistance છે તો resistance develop થવા માટે stress હોવો જોઈએ, yes or no? Tell me. To produce a resistance, we must have stress. So you people already know what is the stress. Stress equal to force by area. So in terms of the resistance is a one kind of the internal force, and you all people knowing that stress is the internal resisting property of material. So can we say that stress equals to resistance by area? Yes or no? Everybody with me? Because it is internal resisting, internal carrying capacity. So can I say that resistance equal to area into stress? So I am erasing this and directly write here equation resistance equals to stress into area. I hope it is clear to all of you. Stress sigma into area, that is the cross sectional area of the element. Now, this is the case number B. This is in general elaboration. Case number B, at a stage 0, where load equal to 0. That means your internal load, external applied load P equal to 0. If your externally applied load P is equal to 0, so can I say that your resistance also 0? Yes or no? Please confirm. Your resistance is also 0. This is your stage number A. Now we are going to apply some load. Okay, now we are going to apply some load on your body. Now we are going to apply some load on your body. If we are applying the load on body, your element will deform, yes or no, depending on kind of the load. Yes or no? Yes or no? Students, please be active in your lecture. As the application of load, your body may deform. That is in terms of the work done. So this will deform one place to another place. Right now. So, and as the application of the load, P equals to P. Okay, P equals to P કહી રહ્યો છું અત્યારે. And at the same kind, there is some resistance also. So resistance R equals to RA because of stage A છે. And similarly at a stage B, what we can do, we will apply maximum force. Now this is a P equals to P, that is some intermediate level of load. For an example, your body, if you apply the load on the body, that is 1000 kilonewton. That is the maximum load. Okay, but this P equals to P is at somewhat about 100, 200, 300 level. Is it clear? What is P equals to PA? That is the intermediate level load. And what is the stage number B? The stage number B is, just a minute. Okay, the stage number B is you have a applied load P equals to P max. Is it clear? આ ચાર કેસમાં કોઈને ડાઉટ છે? સ્ટુડન્ટ્સ, આ ચાર સ્ટેજમાં કોઈને ડાઉટ છે? And resisting force, that is R equals to, but obvious, your resistance will be a maximum. I hope it is clear to all of you. R equal to R max. સ્ટુડન્ટ્સ પ્લીઝ બી એક્ટિવ. આટલી ખબર પડી ગઈ? ડોન્ટ વરી, યુ વિલ ગેટ રેકોર્ડિંગ્સ. અહીંયા ધ્યાન રાખી લો. પહેલા અહીંયા ધ્યાન રાખો, પછી લખજો. ઓકે, ચલો. Hi. So some theory points are like, consider a circular bar of length L. So this length is L. Length of bar is L for all the cases. Okay, હું theory લખતો નથી. Consider a circular bar of the length L and cross-sectional area is A. So length of bar is L and a cross-sectional area is A. Consists of elastic material subjected to load P as shown in figure number A. Okay. Now, in this figure, we have also mentioned 4 different cases, and I have also explained what are that 4 different cases. Yes or no? Yes or no? We have already discussed different cases. So now, let me discuss stage number 0. Stage number 0, that means figure B. Figure B, stage 0. તમે આના ABC પણ સ્ટેજ કહી શકો છો, બરાબર? મેં જસ્ટ 0 લખ્યું છે. At a stage number 0, what is your load P? 0, yes or no? What is load P? 0, yes or no? Now, if your load equal to 0, what will be value of the delta L? What is the change in length? Tell me. Load at 0, 0, change in length કેટલી થશે? Tell me. ચલો fast. Please interact in lecture. If load is 0, what will be your delta L? Okay, good, yes. Now this topic is boring, but it is interesting also. It's, as per my knowledge, yes, it is a but of this boring topic, but it is an interesting derivation. Okay, because from this derivation, from this 4 cases, you are able to understand what is exactly strain. Now it is not possible to elaborate strain energy practically, but from this illustrator example, we can definitely elaborate what is a strain energy. Okay, હું definition તો વાંચી ગયો. But what is the meaning of the strain energy? It will be elaborate from this 4 case on. That's the reason I am covering this topic. So you both are right. At that state, delta L equal to 0. Now, in an elastic limit, if your delta L equal to 0, so can I say that strain is also 0? Yes or no? Because strain equal to delta L by L, change in a length by original length. And if your change in a length is 0, by again, if your force is 0, your stress is also 0. Yes or no? તમારો સ્ટ્રેસ પણ 0 થઈ જશે, અને સ્ટ્રેસ 0 હશે તો રેઝિસ્ટન્સ પણ 0 થઈ જશે. This is for case number B, 0. I hope it is clear to all of you. આટલું ક્લિયર છે? Similarly for stage number A. Stage number A, that is somewhat about intermediate condition. At that point, what is your load? P equals to PA. Yes or no? Yes or no? Yes or no? Please, students, participate in lecture. Suppose this deformation is X. Okay, I don't know what is the intensity of this deformation, but suppose this deformation is X. Okay. So now, if your load is P equals to PA, so can I say that your arbitrary displacement or arbitrary change in a length, that is delta A, delta LA, that is equals to X as shown in figure. Okay, A વાળો સ્ટેજ છે, that's the reason my delta LA લખી છે. That is nothing different. Okay, so now we have a delta L. So now we are able to calculate strain. Strain equals to delta L A divided by original length. So can I say that strain equals to X by L? I hope it is clear to all of you. From Hooke's law, can I say that stress is proportional to strain? So can I say that stress equals to E into strain? We have already calculated strain. We can able to calculate stress E multiply by X by L. I hope it is clear to all of you. Itna clear hai? We can rewrite like this: stress equals to X by L into E. આટલું ક્લિયર છે સ્ટુડન્ટ્સ? પ્લીઝ કન્ફર્મ મી. ચલો, ફાઇન. Now we are interested to suppose in a stage number A, we have applied load P equals to PA. At that time, there is some internal resistance in terms of the strain energy also developed, that is RA. So as we have discussed, what is the equation of resistance? Sigma into A. So now this is a stage A, that's the reason of sigma A. Don't confuse. This is a stage A, that's the reason sigma A. I hope it is clear. And E is the modulus of elasticity, which is a constant for material. Okay, doesn't depends on any level. That's the reason मैं E લખ્યું છે. E નથી લખ્યું. Question ન થાય કે ભાઈ સર અહીંયા E કેમ નથી લખ્યું? Because it is a constant term. Fine. So now, so can I say that resistance equals to RA, and your what is your resistance? Sigma into A. So can I say that RA equals to sigma A? Stage A છે એટલે small a લખું કેમ કે मैं અહીંયા આગળ small a લખ્યું છે into A. I hope it is clear to all of you. So just put the value of the sigma A in equation of RA. We will get X by L E into A. I hope it is clear. Itna clear hai students? Please confirm me. We have calculated sigma A. We have calculated RA. Chaliye. Next, stage B. What is your stage B? At that condition, P equals to P max, yes or no? At that condition, P equals to P max. And at that condition, suppose this your displacement attain maximum level of displacement, because we have applied maximum load, and that is delta L by self. Okay, I know delta L જ કહી રહ્યો છું. Okay, X કેવું કોઈ symbol નથી આપતો. So at that condition, delta L equals to delta L. Stage B છે એટલે હું B લખું છું. What is your strain? Change in the length by original length. So can I say that delta L by L? Similarly, same procedure જે આગળ repeat કરીએ પ્રમાણે. This is your maximum, because you have applied maximum load. Yes or no? Maximum वाला load apply किया है तो आपका strain भी maximum होगा. Let we write properly. Epsilon max. चलिए. So delta L by L. Fine. Similarly, stress at stage B, that would be your maximum stress. Yes or no? And from this equation, stress equals to E into E. Simple. E into strain. Strain at B condition, that is your maximum strain. So we can write like delta L by L into E. I hope it is clear to all of you. Please confirm me, students. इतना clear है? And similarly, resistance at B level, that is equals to R max. Maximum वाला resistance होगा, that is nothing but sigma max or sigma B. You can say here sigma B, or you can say here sigma max. That is your sigma max. Okay, that is equals to sigma max into area. So we have already derived that equation, delta L by L into E into A. I hope it is clear to all of you. इतना clear है? Please confirm me, students. इतना clear है? यहाँ तक कोई confusion है? चलिए. Next. Now what we can do? It is very important. Huh? Let me plotting load P and resistance R. Against deformation for above stages. अलग-अलग stage માટે આપણે draw કરીએ. So let me plot a different conditions. Fine. Nothing. We are here. What we will do? We will drawing a stress versus deformation diagram, or sorry, load versus deformation diagram. Okay, for different conditions. So this is your we are going to plot a two diagram. First diagram that is for load versus deformation, and another diagram is a resistance versus deformation. Okay, in both case, your x-axis will be a deformation. Clear? Both case, your x-axis will be deformation. Delta L. Your x-axis will be a deformation. Delta L. Now, this first diagram is a load versus deformation diagram. Okay. So on y-axis, there will be a load P. I hope it is clear to all of you. And this is a resistance versus deformation diagram. So on y-axis, there will be a resistance. Now, just tell me, if I am applying the load, your body will be deformed, yes or no? Yes or no? And all of you are knowing that we are working under the elastic limit, yes or no? We are working under the elastic limit. So your load versus deformation diagram, both obvious, linearly vary. Everybody with me? Whenever I am applying the load at a different stage, whenever load is increased, your deformation will increase. First stage, second stage, third stage, fourth stage. Okay. As the intensity of load is increased, your deformation also increase. So this is a what we can say. This is a schematic diagram of the load versus deformation. So let me say this is your stage number A. That is the intermediate wala condition. Stage A. Fine. And this is your stage B, that is for a maximum wala condition. I hope it is clear to all of you. So this deformation is your maximum deformation, and this load is your maximum load. Clear enough? This is your P max. This would be your P max. And this is your PA. I hope it is clear to all of you. This deformation is X only, because at stage A, your deformation is X, and at stage B, your deformation is delta L. Same way, whenever I am applying the load on body, at the same time, there would be a internal resistance obeyed by the material of the body. Yes or no? So at the same time, there should be a resistance versus deformation diagram we can plot like this same manner, because again we are working under the elastic condition only. This is your maximum wala condition. This is your stage number A. I hope it is clear to all of you. Stage number B. Again, this is your RA. And this is your R max. This is your deformation X. And this is your deformation delta L. इतना क्लियर है स्टूडेंट्स? प्लीज कंफर्म में. इतना क्लियर है? ये दोनों डायग्राम में इतना क्लियर है? चल फाइन. Let me derive equation. Now, let's write some theoretical point. Strain energy stored during this is strain energy stored during this is obtained by area covered by resistance deformation plot. Okay, समझाओ, don't worry. Strain energy stored during this obtained by area covered by resistance versus deformation plot. Now just tell me, whenever we are going to apply load, your body will deform, yes or no? So this is nothing but deformation taken place. This is nothing but deformation taken place. So kitna work hua? That is nothing but you have to consider area under the deformation and load and area under the deformation and resistance to calculate strain energy. So energy stored at the end of stage A. Okay, energy stored at the end of stage A. Energy stored at end of stage A इंटरमीडिएट वाला पोजीशन बोल रहा हूं, that is nothing but strain energy का symbol है u. U is a symbolic representation of strain energy. That is equals to area that is said like this. ये वाला पोर्शन. Say this is the point O, this is the point D, and this is the point A because of stage A. So can I write like this? That is area shaded region. Area shaded region of triangle OAD. Triangle OAD માં જે region માં shade કરો છે એટલો area, that is nothing but your energy stored during the stage A. Fine. That is equals to 1/2. Triangle દેખાય છે 1/2 into x is your length and what is your y equals to RA. તો અહીંયા લખું છું હજુ ક્લિયર ક્લેરિફાય કરવા માટે OD multiply by AD. Okay, OD multiply by AD કહી શકાય. That is equals to 1/2. What is OD? That is x. This is x into R. I hope it is clear to all of you. Clear है students? इतना clear है? चलिए, we already know what is RA. We already know what is RA. So can I write like this? U equals to 1/2. RA equals to कही शकाय sigma A into area into x. Yes or no? From previous slide, what is R? Stress into area. What is RA? Sigma A into A. Now please don't confuse. मैं यहाँ sigma A capital લખ્યું છે, that is small h છે. સમજી જશો ને? ફાઇન. તમે નોટ્સ લખવા બેસો ત્યારે કોમન સિમ્બોલ રાખજો, બરાબર? ચલો હું અહીંયા ચેન્જ કરી દઉં છું. sigma A. So you can say U equals to 1/2. We have already calculated sigma A. What is the value of sigma A? આપણે sigma A નથી મૂકવું. ચલો પહેલા sigma A into A into what we will do x by L into L કહી શકાય. L વડે મલ્ટીપ્લાય કરે અને L વડે ડિવાઇડ કર્યા. Is it clear? Is it clear? कितना क्लियर है स्टूडेंट्स? मैं कશું જ નથી કર્યું, અહીંયા L વડે મલ્ટીપ્લાય કર્યું છે અને L વડે ડિવાઇડ કર્યું છે. ફાઇન. ચલો, now what is x by L? X by L is nothing but epsilon A. કહી શકાય x by L is nothing but epsilon A. Yes or no? This is your capital L. Clear? So we can write like here U equals to 1/2 sigma A epsilon A into A. I hope it is clear to all of you. Into L. L રહેશે. આવું કઈક ઇક્વેશન બનશે. Students, please confirm me, is it clear or not? इतना क्लियर है? फाइन ना. चलो, in general strain energy is nothing but in general strain energy U is nothing but 1 by 2, what we can say, multiply by stress, multiply by strain, multiply by area. Now what we can say, A into L, that is volume, yes or no? A into L is nothing but volume, yes or no? A into L is nothing but volume, volume of member. Please confirm me students. આના ઇક્વેશન અહીંયા લખી આપું છું ફરીવાર, U equals to 1 by 2 sigma A epsilon A into volume. Don't confuse. Okay, A into A. Why we have divide L and multiply L? Because we are interested to derive equation. Okay, એમાં આપણે તમે જો વોલ્યુમ ને બધા ટર્મ છે એના માટે કરું છું. Okay, so now but question એવો થાય, સ્ટ્રેન એનર્જી નું ઇક્વેશન તો આવું કંઈક છે, સિગ્મા ઇક્વલ્સ સિગ્મા સ્ક્વેર બાય 2E into વોલ્યુમ, બરાબર ને? આવું ઇક્વેશન તો અહીંયા દેખાતું નથી. ચલો આપણે એને ડિરાઈવ કરીએ. Now we can say that stress equals to E into epsilon, yes or no? Yes or no? From that can I say that epsilon equals to stress by E? Everybody with me? Everybody with me? સ્ટેજ નંબર A છે તો બધી જગ્યાએ સ્ટેજ નંબર A નું જ કોન્સિડરેશન થશે. ફાઇન, તો એપ્સિલોન અહીંયા સિગ્મા A આવી જશે, અહીંયા એપ્સિલોન A આવી જશે. So put that value in this equation. નીચે વાળા ઇક્વેશન મૂકો તો લખી શકાય U equals to 1 by 2 sigma A epsilon A ની વેલ્યુ મૂકો sigma A divided by E into volume. Yes or no? Please confirm me. So can I write like this? U equals to sigma A square by 2E into volume. Is it clear? Now is it clear? I hope it is clear to all of you. Students, clear na? Chaliye. Now એટલે again don't એવું ના કહો કે ભાઈ આ જ ઇક્વેશન સાચું છે. You can say this equation is also for a strain energy. Okay, આ ઇક્વેશન strain energy નું સાચું જ છે, કંઈ જ ખોટું નથી. You can use this equation also, but in that case you need to calculate strain. Okay, એમાં તમારે strain શોધવો પડશે. That is now this is a case of the intermediate વાળા location. Now for a maximum વાળા location. Okay, maximum માટે શું કરીશું? ચલો, so for a maximum strain energy sorry, for a maximum strain energy, your equation will be remain same. U max થઈ જશે અહીંયા, that should be equals to, ये पूरा एरिया आपको कंसीडर करना पड़ेगा. मैं ग्रीन मैं ब्लैक कलर से शेड कर रहा हूँ. क्लियर है ना? ये भी आ जाएगा. So 1 by 2, say this is a point C, this is a point B, OC divided by BC. 1 by 2 OC into BC. So we can write like this, 1 by 2 delta L into R max. What is your R max? That is equals to 1 by 2 delta L sigma max into area. Yes or no? Simple છે ને? Simple છે ને? So we have already calculated sigma x. So what we can do, same procedure, L વડે divide કરો, L વડે multiply કરો, 1 by 2 sigma max area delta L by L into L. So again we can write like this, 1 by 2 sigma max area, this is your epsilon at maximum condition into length. Fine na? Clear hai? So we can write like this, that is equals to 1 by 2 sigma max epsilon max. What is A into L? Volume. Is it clear? આવી ગયું આ ઇક્વેશન? ચેક કરો આ વાળું ઇક્વેશન. 1 by 2 stress strain volume of member, 1 by 2 stress strain volume of member. I hope it is clear to all of you. Same way, what we can do, we already derived the equation of the stress maximum. Any value મૂકી દો stress strain ની. So અહીંયા કહી શકાય equals to 1/2 sigma max into sigma max by E into volume. કહેવાય ને, find the epsilon. What is again same condition? Stress is proportional to strain. So what we can do, strain equal to sigma by E. Max એટલે max લખી દો. So what we can say, U equals to U max equals to 1/2 sigma max square by E into V. Is it clear, students? Please confirm me. I hope it is clear to all of you. Concept of the strain energy is clear now. How that equations come. Okay, so now this is a in general condition, and what definition we have discussed, that is a part of the strain. Fine. Sure. I hope this is clear to all. So just a minute, students. I'm taking your attendance, then after you can leave. Just a minute. Is there any question in this lecture? If you have any question, you can ask me. Is there any question? Just a minute, student. I am taking your attendance. Sorry. Okay, that's it for today. Have a nice day. We will meet again next lecture.